You see, there was a time when we chemists, before the syllabus changed, like 2-3 years back, we were also teaching gaseous state. Right? Now, in that, the pertinent question would be, what is the relationship between these three velocities, which is shown in this graph? This is a Maxwell distribution curve, or Maxwell-Boltzmann equation, which is on the top. Okay, and you can see this exponential part over here. That means this particular graph will never, this end over here, right? Okay, this will be more or less a little, this is not exactly the correct graph. This will have a parabolic kind of a beginning. Then once it crosses the top, which is the most probable velocity, and as we go down, you can see the most probable velocity is the velocity possessed by most of the molecules. Okay, check the y-axis. Okay. Then we have average, and then we have mean square. So this graph is a distribution curve at a particular temperature. So now a question that comes is, what are the relationships between root mean square velocity, average velocity, and most probable velocity? Or they can ask you, pointing this to be as A, this to be as B, and this to be as C, and they will ask you, right, what is the relationship between A, B, and C? Or they can simply ask you a question, which is MCQ, either in physics or in chemistry, depending the kind of exam you're giving and what is the kind of syllabus they're having. Right? What are the relationships between these three velocities? Okay. So you might be given these options, which approximately mean these options. Right? So students get confused because they're studying so many things, right? So I'm telling you a small little technique in which, or something that I used to use in my days to remember this. So most probable velocity, there are two words, right? Most probable. So I would think that this is what? 2 kT by m. Okay. Now if you convert the k into RT, then this would become capital M. Okay. That is what you need to remember. What is k? That is the Boltzmann constant. Now for the RMS, I would see R, M, and S. So I would remember 3 letters. So 3 kT by small m, or I would say 3 RT by capital M. Now what you could see, the velocity over here is directly proportional to the root of the T and inversely proportional to the mass of the molecule, of the gas. Okay. Now gases could be monoatomic, diatomic, triatomic. Those are different things. Okay. So simple, you can simply have this graph and then this as A, B, and C. What are the relationships between that? They could either ask you to identify what is B. Okay. And they could give you a problem which is having, say, Vrms, and at a particular temperature is this. Then they will ask you what is then the V average. So by knowing the relationship between Vrms and V average, which is nothing but this one, okay, that's the ratio between these two, one could solve the problem. Now another question which is regarding the kinetic energy. Okay. Now we know the kinetic energy is this. We also know the average kinetic energy is nothing but 3 by 2. This is Boltzmann constant. Now let's convert this to be as RT. Okay, that's for 1 mole of the gas. And so it will be 3 RT by, okay, it will be 3 by 2 RT. R is universal gas constant. So that means what? Kinetic energy is directly proportional to temperature. Agreed? So if you increase the kinetic energy, temperature, the kinetic energy of the molecules will increase. They will move more randomly within the vessel, pushing against the walls of the container. Okay? Now, within the kinetic energy, what is the velocity that is used? Is it most probable velocity, average velocity, or the root mean square velocity? That itself is a question. Alright? So now if you think, if I solve these two equations, this one and that one, what should be kinetic energy equal to? That is your homework. Okay? So in relation to this particular topic, I have discussed what are the kind of problems that could be asked to you